Okay, good afternoon. It seems there's less students attending the class today because of week 7. It's the midterm test week. Okay, about the midterm test, when is it? Tomorrow. Are you in the right module, right place? It's likely you say tomorrow, not 1 week from tomorrow. All right. It's Saturday, right? 5th of October, 10 to 11. Multi-purpose sports hall, 1, right? There will be a sitting plan upload when it's ready. Hopefully Thursday or Friday. So you check before you go for your test, see where you're supposed to sit. All right. And about the midterm test, there are 2 parts. The first part is the MCQ. If I'm not wrong, there will be 15 questions, MCQ questions. I think each of the MCQ questions carries 3 marks. And then there are part B, second part, short questions. I believe it's 3 of them. Each carries 15 marks. So from the marks distribution, you should spend half of your time on the MCQ and half of the time on the short questions. All right. What's the scope of the test? Chapter 1, Chapter 2, Chapter 3, Chapter 4. It's not the whole Chapter 3. Only part of Chapter 3. Up to where? Up to which part? Only up to including 3.2, the joint distributions. So the marginal distributions, the conditional distributions, we're going to continue the discussion of this, are all not covered in the test. All right. But chapters 1, 2, and part of chapter 3. MCQ, short questions. And my only tips is that attempt all parts of the questions. MCQ, no harm to try, right? We did not set a penalty, so make sure that you answer all the MCQ questions. All right. And for the short questions, also give the answers. Do the short questions. Don't leave it blank. Any other questions about help sheet, right? Do we have help sheet? Right? 1 help sheet, right? A4 size, right? Am I right? Hey, I'm not going to sit for the test, so even if I'm wrong, then it's okay. But if you're wrong, then it may cost you something. 1 help sheet, right? A4 size. Can I write on both sides? Yeah, it did not say anything. That means yes, right? Yeah, right. But of course, if you use all the 2 sides, then what happens in the exam? Also allow 1 sheet. Then where do I write the chapter 3, rest of chapter 3, 4, 5, 6, 7, 8, 9, 10? No place to write. Okay, so just write the important thing. Hey, you have 2 hours. 2 hours is not for you to do revision. 2 hours, the help sheet is for you to just help you to remember some of the key important formula or points. All right, it's not for you to do the revision. All right, don't copy the whole tutorials solutions into your 1 piece of paper. Yeah. How many pages of all the tutorial solutions? I don't think it's too many. Some may just squeeze everything, print it out. It's not a good idea. All right. You have to learn, revise, and write down the key important points. Okay, too much for the test. No further questions, right? No? Yeah? Okay, the question is, how about the differentiation, integration? Do we need to know a lot? Okay, what I can say is that we are not testing for integration or differentiation, but you may still require that, all right? But remember, our objective is to test how much you understand about the probability part, right? So sometimes we think it's very obvious, very easy, integration, but it turns out that it will be very hard for some of you, so we cannot help, all right? But remember, our objective is to test your understanding or how much you learn on the probability part. The integration is just as tools for us to get the probability, all right? We are not testing how to do the integration, but we're testing maybe how to get the probability, or maybe find expectation, things like that, all right? So also for the differentiation also, all right? So it won't, if you spend too much time on doing the integration, then that means it's likely that you're on the wrong path, all right? We're not testing on integration. It's not a calculus module, so we're not testing you on integration, all right? It's more on probability. Okay? Okay, so now let's continue our lecture. Oh, before that, may I know when can you access to the webcast? Immediately, 1 day after the actual lecture, 2 days, 3 days? 1 day after? 1 day after? Okay. Because if it's 3 days after, wow, then whatever I announce within 3 days before the test, only you enjoy the privilege to know all what we mentioned in the lecture. But if it's 1 day after, then may be okay. So it's sort of fair to everyone who are here or who are not here. All right. Thanks. Okay. We continue the discussion of Jordan distribution, marginal distribution, and conditional distribution. So remember, the Jordan distribution, f of x, y, tells you everything about the behavior of these two random variables x and y jointly. Then we would like to find out from this Jordan distribution the marginal behavior of just x or y alone, or given x a certain value, then how does the random variable y behave? Or given y equals certain values, how does the random variable x behave? All right. So here we have, for this example, okay, so we have this restaurant, we have this drive-up facilities and walk-up window. So you can order through the drive-up, or you just walk in and then order through the walk-in window. This is referring to the same restaurant, same fast food restaurant. So in other words, we are looking at one individual restaurant, and there are two variables. One is time serving at the drive. One is the time being used in these drive-up facilities. The other one is the time being used for this walk-up window. All right. Now this is the form, the PDF given to us. Now when you look at the PDF, f of xy, so this function is a function of xy. This is a function of xy. Means that you can see x, you can see y there. Is it still a function of xy if you don't see an x there? So it's still considered as a function of xy. A constant is also a function of xy. It simply means that for any given value of x and y, the f of xy equal to the same value. So it's still a function of xy. So what I mean is that, okay, so any xy that you know, it will map to f of xy. All right, so this f of xy can be the same. That means all the points map to the same point. So that is a constant function. So it still considers a function of xy. Another thing that you have to pay attention is that, remember, and this is very important, the functional form here, which is 6/5 times x plus y squared, this must, this functional form values only when x lies between 0, 1 and y lies between 0 and 1. All right, outside that region, it does not equal to that expression. In fact, you ask, then what is it? So the answer is yes. Otherwise, that means outside that region, the f of xy equal to 0. All right, so it's important that you have to know this functional form in this question only valid for x between 0, 1 and y between 0, 1. All right. And also the second thing that another thing that you have to supposed to worry or check. Make sure that the f of xy is bigger or equal to 0. All right. So this bigger or equal to 0 is okay, right? Is it obvious? F of xy bigger or equal to 0. Is it obvious? Thank you. The others don't know, right? Maybe it's too obvious to say yes. Right? Yes, it is definitely very obvious. Why? Because x is bigger than 0. Y is bigger than 0. So x plus y squared is bigger than 0. Bigger or equal to 0. Okay. So therefore the f of xy, the whole thing is bigger or equal to 0. No matter what your x and y are. All right? But that's another thing that you're supposed to aware or to check. What is it? Is this a PDF? It's bigger or equal to 0 and 0 otherwise. Is it a PDF? We don't know, but you need to check. I've copied the same expression, but what I change is the region. So over that region, I define a function in that form. So now the question is whether the PDF sum up or integrate with respect to x and with respect to y is equal to 1. So basically that means that the area, the volume under this curve surface, all right, for x bigger than 0 and y bigger than 0, the volume is equal to 1. The volume is equal to 1. And in fact, this is not true. Because if what I have here, if this is a PDF, then this cannot be a PDF, right? Because this over the region, in fact, this is infinite if you integrate over the whole real R square plane. So my point is that you have to aware of this subtle difference. That John PDF has to be bigger or equal to 0 and integrate over the whole region has to be 1. All right? Okay, so what we are supposed to do, so we are asked to find the probability neither facility is busy more than 1/4 of the time. Now, it's important that you have to understand the question and then translate it into probability statements in terms of random variable x and random variable y. All right? Now here it says that neither facility is busy more than 1/4 of the time. All right? So in other words, this one means that x more than 1/4. So more than 1/4. But neither, that means the complement of it. All right? Or y also have to be, all right? So that's what it means. Okay, neither is just the opposite of either. All right, so here it say that x is bigger than 1/4 and y bigger than 1/4, but neither of them happens. So that means it can be a complement of x bigger than 1/4 or the complement of the y bigger than 1/4. To translate it, it means that it is x between 0 and 1/4 and y between 0 and 1/4. Okay, strictly speaking, that's what this is equivalent to x less than 1/4 and y less than 1/4. More than 1/4 of the time. It doesn't matter where you put the equal sign because it's continuous random variable. More than 1/4 of the time supposed to be greater than, then the complement supposed to be less or equal. All right. So if you really want, you can put back the equal sign there. All right. But x less than or equal to 1/4. Why is that so? Why are these two the same? These two events, are they the same? So I want you to differentiate these two events. Okay, so I want you to differentiate. These two events are not the same. All right? One is x between 0 and 1/4. The other one is x less than 1/4. That means x less than 1/4 covers this x between 0 and 1/4. In addition, they also include x less than 0. All right? But in terms of probability of both events are the same. The probability, because the probability of x less than 0 is equal to 0. Okay, this event will never occur. So in other words, what I'm trying to do is to express this into x less than 0 and x between 0 and 1/4. All right, two events. So they're mutually exclusive. Therefore, the probability of this is equal to probability of this plus probability of this. But probability of x less than 0 is equal to 0. There's no density there. No density, so you cannot get any probability. All right? So I can write it like that. If you want, you can put back equal sign here, but it will not make any difference when we try to compute. Okay? The second part asks us to find the probability distribution of the time that the drive-up facility is busy without reference to the walk-up window. What does that mean? It simply means that, okay, we don't care about what happens to the walk-up window. That means we don't care about the y values. We just want to know about the behavior of x. So in other words, we are looking at the marginal of x. So what does it mean? It means that we don't care about the y. So what we do is try to combine all the f of xy with the same x value. So how can we do that? We just do the integration, integrate out y. That is the same as summing up all the f of xy with the same x value. We don't care about the y. We just sum them up, all the f of xy with the same x value. All right? So then from there, we try to work out the probability of drive-up facility is more than 1/4 of the time, but less than 1/4 of the time. So, in other words, we are looking at this probability. More than 1/4 of the time, and less than, okay, so it's strictly inequality. So we are asked to find this probability. Okay, so it's important that from the word problem, from what you're asked to find, which are stated in words, to translate it into the random variable x and y, and a probability statement involves x and y. All right? So we have part C. So given that the driver facility is busy 80% of the time, so you can think of it like this. So now, if the drive-up facility is busy, is used by 80% of the time, so will the walk-up facility behave differently? So that's the idea. So intuitively, maybe wrong, but intuitively, if the other facility are more busy, then that means it may be a very busy time. So that's one thing. So I expect that our x will behave differently. That means the x is more a chance to have a high value, more busy. All right. Of course, another possibility, because the drive-up facility is so busy, 80% of the time, some will just park the car and then walk in and buy their food. So it will also make it the x behave differently. So we are asked to find out. So we are asked to find what is the chance that the all-in facility is busy at most half of the time. All right. So you have to translate this into a probability statement. So here, y, what is drive up? Drive up is x, right? Yeah, drive up is x. So we have x equal to 0.8. Remember, 80% means 0.8. All right, so x equal to 0.8, and then y is the walk-in facility is busy at most half of the time. So we are asked to find this probability, a conditional probability. So in order to do this one, to find this probability, we need to compute the marginal distribution. Once you get this conditional distribution, then you can compute this probability. And again, let me remind you, this expression, conditional distribution, here there's only one random variable, which is the y. All right? X is no more a random variable. X is fixed at the value little x. So in this example, we have fixed x at 0.8. All right? Then we want to know how does this y behave if x equal to 0.8. And we want to compute what's the chance that this random variable y is less than half. All right? So that's what. Then, if given that it is BC, the drive-up facility is 80% of the time BC, then what is the expected proportion time of walk-in facility is BC? So this translate means that we want to find the expectation of y. All right, so for any random variable, usually you would like to know what is the chance that the random variable fall within certain region, and also we would like to know what is the expected value of this random variable. Expected value can be interpreted as sort of like a center of the distribution, although it's not necessarily exactly the center, but it gives you some idea that that is where maybe the majority of the values or the values around this center has a higher probability of occurring. All right, so how to do it? So the first one, to get the probability of x between 0 and 1/4 and y between 0 and 1/4. So we do the integration. So, picture here. Oh, no picture. Okay, so remember our x and y. So the PDF is defined over this range, this unit square, and what we have is x between 0 and 1/4, and y between 0 and 1/4. So we are looking at this, not this area, but the volume covered by, you can think of it, something come out from this screen, all right? It represents the PDF, the JOHN PDF. And then you are basically looking at the volume under this curved surface coming out of the screen, which represented by the f of xy, and under this region, this small region, x between 0, 1/4 and y between 0, 1/4. All right? So in that case, we do the integration. So integrate the JOHN PDF. All right? So here we integrate x first, which means that we fix y. We fix y and integrate x. So the limit is from 0 to 1/4. So from 0 to 1/4. All right? From 0 to 1/4. Now, it looks very easy, but you have to understand why is it 0 to 1/4, because we are looking for x, for the region for which if you fix y, then the x is from 0 up to 1/4. All right? After that, then you can consider the next step is very crucial, how to determine the integration limits. All right? So before you do anything, you have to think of it. After you complete this integration, all right, no more x. So what does it mean? It means that now instead of a two-dimensional, you can think of a curved surface, coming out from the screen, but now everything will be squeezed. This region, this whole R square will squeeze on this line. This line. So there's nothing here, nothing, no PDF here. So when you squeeze, this part has no density. While this part, you have density. So now what we are doing is to squeeze everything. So we are looking at all the density over this part, now concentrate on this part, where y is from 0 to 1/4. That's why we integrate from 0 to 1/4. Now why I have to stress that? Because, all right, in some other problems, the region may not be a square or rectangular. Then you have to understand that when you squeeze it, all right, for example, let me draw another example. Suppose I'm looking at this, all right? Let's say 1/2 and 1/2. I'm looking at this region. So when I integrate x first, so I fix y. So I integrate from this point to this point. Now this point, the x value is 1/2. But this point, the x value depends on y. And in fact, let's say this is x equal to y. Then this x is equal to y. So the integration limit is from y to 1/2. All right? But then if you look at this part, it is from 0 to 1/2. There's nothing here. So if you integrate, then you may think that, oh, y is just 0. But no, after you integrate x, you squeeze everything. So that means you think of it, you have two plans. You try to squeeze everything. So all the density will be concentrated onto one line. So let's use this line as a reference. So all the density will be squeezed on this line. So this part, no density, so it's 0. This part will have some density after you squeeze it. If I look at this part, all right, so y will be from 0 to 1/2. All right, so it needs some practice to get the integration limit. All right, so I also apply the idea that, okay, this is basically two terms, so I integrate x as one integration and then y squared as another integration. So in that case, it's easier to work with, right? It's nice that now I just look at integration with a function that involves x only. This one involves y squared only. So immediately I know that this is equal to y squared times x, where x is from 0 to 1/4. All right? So it becomes y squared divided by 4, this part. So it's quite straightforward, easy to compute. This one will be x squared over 2. from 0 to 1 quarter, 0 to 1 quarter. So this is the way that we do it. All right. And so it becomes like this. All right. So this is after you complete the first integration. Is that what you get? And then continue to integrate with respect to y. And the answer is 7/640. So the chance is very small that x is less than, when y, So the chance that x less than 1 quarter and y less than 1 quarter is very small. It's about 1% only. You can see that because this is the PDF. So we can see that as x getting bigger, then this is big. All right. But of course, when y is getting bigger, if y is getting bigger, how about y square? Getting bigger? Yeah, no. Why no? You have a calculator? What is 0.9 square? Is it bigger than 0.9? 0.5 square, is it bigger than 0.5? Is 2 square bigger than 2? Yes. And because y is between 0 and 1, when you square it, square number less than 1 is getting smaller. All right? But anyway, it's more determined by x, also plus y squared as well. But it has an impression that this one is getting bigger if x is getting bigger. So that's why you're looking at x between 0 and 1 quarter. It cannot be very big. All right. Okay. So my point is, okay, if you get the answer, if the answer turns out to be 0.95, then you may suspect there's something wrong with the integration. Why? Because the PDF seems to have a smaller density where x and y, and where x is small, all right? And y is small as well. But where x big, y relatively big, we expect a bigger density. So the PDF should be big. So this probability we expect to be small. All right? So f of x, we just try to integrate out y. So we do integrate from 0 to 1. And then the answer is 6/5 x plus 2/5. Is it true for all x? Is this true for this probability density is true for all x? And the answer is no. Why? Because when we substitute this part, we are assuming that x is between 0 and 1. All right, x has to be between 0 and 1. All right, in fact, it's not just x between 0 and 1. Y has to be between 0 and 1, but we are already taken care of here. So it's valid for x between 0 and 1. Then the next thing, how about outside this range, 0, 1? What is the PDF of x? What is f of x if x is outside this range? 0, right? But why is it 0? Why? It's just like that, right? Why? Because what you're given is the John PDF. What does the John PDF tell us? The John PDF tells us that it will be 0 if it's outside the unit square, x between 0, 1 and y between 0, 1. So you are told that the John PDF will be 0. So if you follow the integration, you integrate, all right? All right? So you look at f of x, then will be integrated from 0 to 1 dy, in fact from minus infinity to infinity, all right? That one will be 0 for x less than 0. Because for x less than 0, the John PDF is 0. So it is equal to 0. All right. So I want you to, when you look at all this, especially anything to do with the mathematics, they are very rigid. Okay, it's not just, oh, it is 0, it's like that. No. Here what we're given is a John PDF. So everything will be derived based on the John PDF. All right. So the John PDF tells us that it's only equal to that particular formula, or close that mathematical formula expression only when x between 0, 1 and y between 0, 1. Outside that will be 0. So you just try to get the marginal f of x through the integration. Integrate out y. But the whole thing is 0, so your integration, the answer is 0. So it's 0 otherwise. Okay, then how to get this probability? So we just use the marginal distribution, integrate from 1/4 to 3/4. And the answer is 1/2. All right. I have this question. If I go back to this, right? So, what happens if f of x equal to, okay, where x equal to 1, right? Including 1, right? X equal to 1. I substitute x equal to 1, then it is 6, 5 plus 2, 5. Is this number bigger than 1? 8/5 is bigger than 1. Anything wrong? Anything wrong? Nothing wrong. This is not a probability. Let me repeat. It's not a probability. This is a probability density. So the density can be bigger than 1. All right? But it just compensates by for some other x value, the density is smaller than 1. So the whole, as a whole, the sum or the integrate after the integrate is still 1. All right? So the density can be 1. That means in that particular neighborhood of 1, it's very dense. All right? The density is 8/5. All right? So, but how about x equal to 0.1? X equal to 1/10, then your density is very small. All right? So in that case, it will balance, solve like some region with low densities with high density. So as a whole, the whole thing will have a combined, integrate the John PDF is equal to 1. All right? So I just want you to make sure you understand for continuous distribution, the f of x is not a probability, but a probability density. Probability density. So it can be bigger than 1. Can be bigger than 1. All right, so now part C. So we try to get the conditional distribution. So this conditional distribution is equal to John PDF with x equal to 0.8. All right, and then after we simplified it, it's equal to this. Now since we are given that the random variable takes the value 0.8. So if x equal to 0.8, how does the y behave? That's what we will try to look at. All right. So we substitute x equal to 0.8 into the conditional distribution. Now it's not true that this is not what we want. This does not represent a behavior of y when x equal to 0.8. All right? Why? Because it simply say that, okay, when x equal, okay, you can think of it So the John PDF is defined over this region. So now I look at 0.8. So I look at the density. This represents the density over here. Now the problem is the density over this part. All right. So in other words, you are looking at this whole thing. All right. This density does not integrate equal to 1. Does not integrate equal to 1. What? Is this whole, the volume, you think of it, something come out, so the volume of under this curved surface over this region is 1. And now you just look at part of it. So this will not integrate equal to 1. So to adjust it, so this is the adjustment that we did. So we adjust with, if you recall, maybe continuous is difficult to see. Let's look at, recall the simple example of, let's say 1, 2, and this is y takes 1, 2, 3, right? This is a John density, all right? So I may have, let's say 1, 6, 1, 6, 1, 6, all right? 1, 12, 1, 6, and so this one is 3 over 12. Yeah. Right, so this one is, yeah, so it's 1, 6. Okay, so now what I mean here is that, okay, now you just look at this part. So this is 1, 6, 1, 6. That means with x equal to 1, we know that f of xy, or f of x, f of 1, 1 is 1, 6, f1, 2 is 1, 6, f1, 3 is 1, 6. But these three numbers does not add up to 1. These three numbers do not add up to 1. So that means this is not a proper PDF. So what you do, you have to divide by, adding up is 1/2. So each one will be divided by 1/2 to make it the sum of all these numbers equal to 1. So the same apply here. This John PDF, so the PDF over this line will not integrate equal to 1. So we have to divide it by the marginal of the x equal to 0.8. I just want you to know that you cannot simply use this one as a conditional distribution. When I say that, oh, given x equal to 0.8, how does y behave? So if you just give me this part, or in other words, this line, it's not good enough because it's not a proper density. So that's why we need to adjust it by the marginal. So that's why it is f of xy divided by f of x. That is the marginal distribution. We have just to make it into a probability function or probability density function. All right. So that's why we need to divide by this, and it turns out to be this. All right. Okay. So given x equal to 0.8, so now our conditional distribution should not have any x anymore because x is already fixed at 0.8. All right? So you don't see any x there. Of course, the next question is this expression, conditional distribution equal to 3 times 4 plus 5y squared over 17? This expression is valid for all the y values. And the answer is no. Why? Because when we substitute this with this, the numerator, this expression only valid when y is between 0 and 1. All right? Between 0 and 1. All right? So this is only valid for y between 0 and 1. Outside that range, then this will be equal to 0 for other y value. So this will be 0 for other y values. So John PDF will be 0. So therefore, the conditional distribution will be 0. Okay? So then, so we compute the probability of y less than half. So supposed to integrate from minus infinity up to half of the conditional distribution. Remember, only one random variable, y. So I integrate with that's y. All right. So, and suddenly this one changed to 0. Why? Because I break this integration into two parts, from minus infinity to 0, and the other one is from 0 to half. 317, 4 plus 5y squared dy. So this is 0. All right. So the answer is 0.3897. Okay. So it will be interesting to look at if you compute this probability and compare them. All right. Do you think that they are the same? Right? This is probability of y less or equal to half. This is probability of y less or equal to half. But this is condition on x equal to 0.8. This one, no condition. So in other words, this one, without the x, means that we have considered all possible scenarios. We take into consideration all the possible x value. In other words, we don't care about what the x value. I just look at the chance of y less or equal to 1/2. While the other one, the conditional one, is that, okay, now we know that x is equal to 80%. It's very busy, relatively busy. Then what happens? What is the chance that y is less than 1/2? What is the chance y is less than 1/2? So this is different from, okay, I don't know anything about x. So I just ask, what is the chance that y is less or equal to 1/2? So it can be, x is very small. X is, let's say, 0.1 or 0.15. All right? So also x can be 0.8, can be 0.9. So we combine all this. We don't care, basically. Don't care about the x. All right? So we combine all just look at y less or equal to half, disregarding what x is. So this, we have to look at the marginal distribution of y. And in general, these two are not the same. The marginal distribution and the conditional distribution are not the same. Therefore, the two probabilities that I list here are not the same in general. Of course, sometimes they are equal. Then, of course, mathematicians ask, so what is the time that they are equal? So that leads to the next section about independent random variables. If x, y are independent, then these two probabilities will be the same. In other words, it doesn't matter what your x value is. All right, that's called independent random variable. All right, so finding expectation. So follow the definition. It will be y times the conditional distribution of y. All right, so from minus infinity to infinity, and then I replace it by 0, 1 as the integration limit because the conditional distribution will be 0 outside this range. So we do the integration, and the answer is 0.5735. Okay. Now, let's move on to have a similar example, but we are not given explicitly what is the f of xy. We are just told that xy are uniformly distributed over a triangular area bounded by this. So there are two things here. First of all, you must be able to identify the region. This region is bounded by all these 4 inequalities. What are the 4 inequalities? X greater than 0. All right? If you draw the picture, x greater than 0. That means it is all the region on the right-hand side of the y-axis. And also x less or equal to y. Then you have to draw a line, which is y equal to x. And then x less than y. So which part? So to identify which part, you just arbitrarily take one point. For example, you take this point. This point, let's say x equals 0 and y equals 1. All right? Then in this case, you put it in, and it satisfies this inequality. Now, if you take this point, this is 1, 0. X equals 1 and y equals 0. Then this will not satisfy. So in other words, this point is not, but it does not satisfy this inequality. Therefore, it is all these points. So the intersection of these two inequality is this area. All right, this part. The rest do not satisfy this inequality. Now then we look at the y. Y, the first inequality is y less or equal to, y is bigger or equal to 0. So that means anything above this. So already we have no contradiction to what we just have. Then last one is y less or equal to 2. So draw a line y equal to 2. All right. So this is the region. This is the line y equal to 2. So you must be able to identify the region. All right. So it's a triangular region. And the John PDF is non-zero over this region and will be 0 outside this region. Okay. So now, so we are not told what is the f of xy, but this word uniformly distributed, which means that so long as the xy is within this triangle, then the PDF will be the same. Will be the same. It doesn't matter whether the point is here, or the point is here, or the point is here. No, so long as it's within this triangle, they will have the same PDF. Of course, what is the PDF here? It's 0, because it's already outside the region. All right? So, we are then asked to find the John PDF of xy. You are not given. What you're given is only a word saying that it's uniformly distributed over this region. Then find the marginal x, marginal y, and then find the conditional of y given x and x given y. Lastly, find the probability of x less or equal to 1/2, given that y equal to 1. And also find the probability of x less or equal to 1 and y less or equal to 1. All right? So to begin with, this is how we usually do. Uniform. That means all the same, so long as this is true. So we let it equal to k. So here comes, and then how to solve for k. So we must set up an equation. So the equation is, we know one fact. Integrate from -infinity to infinity, this, the John PDF, is equal to 1. So this is an equation. You just have to construct this equation. How? So it turned out to be integrate, okay. So if we integrate x first, so x is from 0, remember, this is the region, right? 2, okay, 2, 2. So that's why this point is also 2, because this line is y equal x. So we are looking at this region, all right? This thing. So if I integrate x first, that means I fix y. Fix y. So it is from 0 to y. All right? And then, what is the PDF? The PDF is the same, so it's k. After that, which means that now I squeeze everything. You can think of it, there are two planes. So squeeze every density onto this axis. So now only this part have non-zero density. The rest will have 0 density. So we integrate from this point, y equal to 0 up to this point, which is 2 of dy, and make it equal to 1. So that's how we set up an equation involving the unknown k. All right? Let me repeat this. We need to solve an equation that involves k. How to set up this equation? We make use of a well-known fact that integrate over x and y of the John PDF has to be equal to 1, from -infinity to infinity for both x and y. All right? So that is the general truth. This is always true. All right? But now the question is that you have to substitute the right thing. So we substitute the PDF, which is non-zero, over this region, this triangular region. So then we integrate. So integrate from, for integrate x first, that means you integrate fixed y and integrate x. Now the same thing, let me just sidetrack. So what happens if I want to integrate y first instead of x? So I have to fix x and then integrate y. So fix x. So now I integrate y first. So at this point, okay, what is the y value? Fixed x. So this point, y equal to x. So I integrate from x to this point. So integrate from x to from y equal x to y equal 2. At this point, y equal 2. All right. So integrate this part. So it looks as if now I try to squeeze everything onto the x-axis. So everything is on the x-axis. Then only this part from 0 to 2, that with non-zero density. This part, 0 density. This part, also 0 density. All right? So now the x is from 0 to 2. 0 to 2. Okay? So the lesson is you can do it either way. Integrate x first and integrate y first. So hopefully you know how to set up the limit, how to do it properly for integrate x first or integrate y first. You should get the same answer. Then if you have two ways to do it, the next question is, which one is better? Integrate x first better or integrate y first better? What do you think? Huh? So, I love zeros. Huh? So this one should make it easier to work with, right? Because we substitute 0 into it to cancel a lot of the terms. All right? So, so this integration may be easier to work with. All right? But it's just it just sidetrack. All right? It doesn't matter which one you use. But if you pick the right one, maybe easier to work with and less chance to commit an error. All right? But it's not important. So long as you do everything is correct. The important thing is to know how to set the integration limits. Okay? So, there's another way to look at this one. After so much hard work, k turned out to be 1/2. All right? And a simple way approach for uniform distribution is just look at the area for which the PDF is non-zero. So the area of this triangle, what is the height? The height is 2. What is the base? The base is 2. So the area is 2. So therefore, the area is 2, and I have a uniform, think of it, you have a surface which is flat, all right? And the volume under this surface, bounded by this triangle, has to be 1. So the height of this surface, this surface has to be 1/2. So that the volume is 1/2. This is the PDF times this is the area of the region. All right? Sorry. Yeah. Okay. So sorry. Hey, yeah. You see, I make the same mistake. When I see 1/2, because the answer is 1/2, so I tell you it's 1/2. But this is not the 1/2. This is the area. 1/2 times the base times the height. This 1/2 is the formula to compute the area of the triangle. So this is the area. All right? So your height times the area, you have to make it to 1. So therefore, k is 1/2. You understand? So the area is 2, and the height is k. So in order to make this volume is 1, so therefore k must be 1/2. All right? Easier, right? Yeah. Okay. So this is how we get the answer. K equal much hard work, we arrive at k equal to 1/2. All right? Okay. So now, I write down the John PDF. F of x, y is equal to 1/2, a constant, does not depend on x and y, so long as x between 0 and y between 0 and 2. Then the f of x, y equal to 1/2. Outside that range, it is 0. All right? So now I want to get the marginal of x, so I have to integrate y. So remember, this is the region, and now I want to integrate out y. So that means for any fixed x, I have to integrate the y at this point is equal to x, and this point y is equal to 2. So it's integrated from x to 2, the John PDF. And this is valid so long as x is within this range, 0 to 2. Outside that, the John PDF is 0. So it is 0 otherwise. So it turns out that the marginal of x is equal to 1/2 times 2 minus x, when x is between 0 and 2. Okay, so this is after we calculate it. But in fact, you look at it, now, throughout the region of this triangle region is uniform. But then you can see that for the marginal of x, for example, if x is a small number, then the density is bigger than if x is big, right? As you can see from here, okay, from this, you can see that at this point, you have more density, that you try to collect all this density to fall in this point, so you have a higher density. While if x is here, then you only have this part of the density that you can integrate, or you can add up. So it is smaller. So it reflects by this expression is 2 minus x. So if x is small, you have a bigger density. If x is large, you have a smaller density. Okay, so similarly for the marginal density of y, it is y over 2 whenever y is between 0 and 2. So again, you can see that it's the same explanation. All right, you can see that if y here, then it collects more density because it's a bigger density, a bigger region for which the density is non-zero. So it just collects all the density at this point. So of course, bigger y means bigger density, higher density. So it's y over 2. So another lesson, over this region is a triangular. So therefore, although the John distribution is uniform, but the marginal is not uniform. That means for x and for y, the distribution are not uniform. Okay, so how about the conditional distribution? So I have to say that when x is between 0 and 2, all right, then the marginal distribution of y given x is equal to the John distribution divided by the marginal of x. And this is valid when y is between x and 2. Wow. So you still have to look at this picture 2, right? So we are looking at force of fixed x. This means that x is fixed. Fixed x, all right, at a particular value. Then the distribution of y is valid from this point to this point. That's why it is bounded by y equal x and y equal 2. Why we have this region? Because the John PDF is defined as 1/2, only valid for this one, so long as x is between 0 and 2. X is between 0 and 2. If x is here, all right, then what is the PDF? Where x is here, then the John PDF is 0. There's nothing here. All right? So this one is 0. So you don't bother about specifying this one. So it's only valid when x is between 0 and 2. Then you have this. And this is valid only when y from x equal to 2. All right? Remember, this equal to this expression, you have to check the following. First of all, the y must be between x and 2. Not only that, x must be between 0 and 2 in order this expression is valid to represent the conditional distribution. Outside these two regions, if this is not true, then it's 0. If this is not true, the PDF is, the conditional distribution is also 0. All right, so you simplify it, it becomes like that. All right, then similarly, okay, so here, so when x equal to 1.5, I substitute 1.5, then I got the conditional distribution where x equal to 1.5 is equal to 2. So long as y is between 1.5 and 2. So again, this shows you that the density function can be bigger than 1. All right. So long as y is between 1.5 and 2, then the conditional distribution is equal to 2. Is this a uniform distribution? Uniform means that so long as the y, in this case the random variable is y, so long as the random variables takes the values within the specified region, which is this one, y between 1.5 and 2. So you look at this, does it depend on the y? It does not depend on y, so it's uniform. That means so long as y takes the value between 1.5 and 2, the marginal distribution will have the same density function, which is 2. In fact, you can see that. What is this width? Between 1.5 and 2, that means the width is equal to 2 minus 1.5. So the width is 0.5. All right, so you can think of it, this is the marginal of y given x. All right, so sorry, this is the wrong graph. Right. It's between 1.5 and 2. We're looking at the conditional distribution. So it's simply saying that when y takes the value between 1.5 and 2, then you have this height is equal to 2. Outside that, it is 0. So it's 0, 0, and 2. And this width is 0.5. 0.5 times 2, so the area under this curve is equal to 1. So it's a uniform distribution because this one does not depend on y. So long as y between 1.5 and 2. All right? So otherwise, the conditional distribution is 0. Okay, then how about the margin of x given y? So we just repeat the process. All right, so it's the John PDF. Now this time, look at it. So this is the John PDF. So now I look at fixed y, and look at how the x behaves. So x equal to 0, and at this point, x equal to y. All right. So within this range, x between 0 and y, the John PDF is equal to 1/2. Outside this range, the John PDF will be 0. So within this range, all right, this range, y between 0 and 2, then this one equal to y over 2. So we take it, this is valid and this is valid, then the marginal is given, the conditional distribution is given by this expression. If this is not true or this is not true, then it will be 0. Okay? So simplify it, you'll get 1 over y. So is the conditional of x given y a uniform distribution? And the answer is no, because the distribution depends on y. It's 1 over y, depends on y. So it's not uniform. That means it's not the same anywhere when x is between 0 and 1. It's different. It's equal to 1 over y. So it's not a uniform distribution. All right, then So after we simplify it, it's equal to this. So if y equal to 0.5, so then the x given y is a uniform distribution. Oh, I'm sorry, I confused her. It's uniform distribution. I'm sorry. I confused. We are talking about random variable x. Remember, don't make this mistake. The random variable that we are talking about is x. Does this one depend on x? No. So the conditional distribution is uniform. But of course, the PDF depends on y, depends on the y that you condition at. All right. So the conditional distribution of the random variable x given y is uniform. All right. But the value depends on y. The PDF depends on y. All right? So it's important that this is the random variable, x, that we are talking about. So when we say whether x, the condition of x given y is uniform or not, we look at this expression, whether it involves any x. So no matter what your x is, so long as x is between 0 and y, then it is the same, 1 over y. All right? So when y equal to 0.5, then the distribution is equal to 2. How about this? What is this? Is it 1 over 3? This means that when y equal to 3, how does x behave? Is it equal to 1 over 3? Substitute this by 3. No, this one does not equal to 1 over y, and substitute y equal 3. No, it's equal to 0. Because this only valid when x is between 0 and 2. Outside that, it's not that. Okay, outside that, it will be 0. It will be 0. All right? Okay, so now next we want to compute this probability given y equal to 1. So we just apply the conditional probability when y equal to 1. So the answer is 1/2. This one is equal to 1 over y. So we replace this by 1. All right, the limits, integration limit is from -infinity to 1/2. So this is equal to -infinity to 0. And the PDF, the conditional distribution is 0, and then from 0 to 1/2. All right, which is 1 over 1 dx. So the answer is 1/2. So again, it will be interesting. Try to see whether you can get this one and see whether they are the same. What is f of x? Let me go back and check what is f of x. F of x is equal to this one. All right? So long as x is between 0 and 1/2. So what is the probability of x less than 1/2? So we substitute, we integrate, not substitute. We integrate from 0 to 1/2, 2 minus x dx. See whether this is equal to 1/2. If they're not, then that means the two are not the same. The conditional and the unconditional are different. Okay. Okay, the last part, to evaluate this John probability. So this is the part. So what I did is to integrate x first. That means I fixed y. So at this point, x equal to 0. At this point, x equal to y. So the integration limit is from 0 to y. So after I complete the integration, then everything is squeezed onto this line. So now the part that with the density that we're interested is from this point to this point, where y equal to 0 up to this point, y equal to 1. So it's integrated from 0 to 1. All right. So we integrate. So the answer is 1/4. All right. As a check, it's very simple. Think of it, right? This is your area for which the joint PDF is defined. All right. So in fact, there are 4 parts, 4 equal parts. And because it's uniform, I have to stress this uniform density. So therefore, the probability over this shaded part basically is 1/4 of the probability of the whole thing, right? And the probability of whole area, whole region is 1. So you just have 1/4 of it. So the answer is 1/4. If you don't get 1/4, something wrong with your calculation, right? Because the beauty about this uniform distribution, we just look at the region. And the region, I can compute the area easily. So it's just this one. The region is 1 times 1 times half. So it's half. Half out of the total region and total area is 2. So it's half out of 2. So it's 1/4 of the whole thing. All right, so the probability is also 1/4. But not always have this nice thing about uniform distribution. All right, so you better know how to do the integration, how to compute it through integration. Is this the same as this one? Is this probability the same as this probability? In general, no. If this holds, what does it mean? It means that x less or equal to 1 and y less or equal to 1, these are 2 events. All right? So it's saying that the probability of A times probability of B equal to probability of A intersect B. This means that A intersect B, both events occur, A intersect B. So that means A and B are independent events. And in general, this may not be true. All right? Okay. We have independent events, so now we look at independent random variables. So what are independent random variables? So if we have 2 random variables, x and y, we say that they are independent if and only if that the joint PDF is equal to the product of the 2 marginal. So this is a much, much stronger condition than the independent event. Independent event, you just have 2 events. You look at the probability of the intersection of the 2 events equal to the product of the 2 probabilities of these 2 events. Then they are independent events. But here it's not just 2 independent events. You are talking about many of the independent events. Basically, we're talking about 1 random variable is independent of another random variable. So this is the definition. And this definition applies to both continuous and discrete random variables. One very important point. This relationship, f of xy equal to f of x times f of y, is valid for all the xy, That means x can be from minus infinity to infinity, y can be from minus infinity to infinity. All right, true for any xy. Wow, headache, huh? So it's true for all xy. Don't have to check all the xy. All right. So yes, it's true for all xy. And this definition can be extended to n independent random variables, x1, x2, up to xn. So these n random variables are considered as independent if the John distribution is equal to the product of the marginals at each of these values, where xi is equal, for any xi, any x1 value, any x2 value. All right. So that's the definition of independent random variables. And one important point, something called product space. What does that mean? It means that if f of x is bigger than 0 over a certain region, I just call it A1. It can be from 0 to 1, or can be from 0 to infinity, can be from minus infinity to infinity. So A1 can be any of this, all right, over a region. So similarly, y is bigger than 0. Remember, we're talking about bigger than 0. So outside this region, the probability density will be, or probability function or probability density will be 0. So y in A2, it is bigger than 0. The f of y is bigger than 0. Then, so when we take the product of the two bigger than 0, okay, it's supposed to be valid, all right, for any point xy over the product space. What does it mean? It means that if x over this region, the PDF is bigger than 0. The f of x is bigger than 0. And then over this region, for y, it is over this region. Then the PDF is bigger than 0. Then the product of this f of x and fy should be bigger than 0 over this, we call it product space. Product space. So this is my A1, this is my A2, the region A1 and A2. So this is A1 times A2. So for any point here, the product will be bigger than 0. Come to think of it, f of x is bigger than 0 for any x value here. And f of y will be bigger than 0 for any y values here. So when you multiply the two non-zero, it is bigger than 0. So therefore, any point here, all right, x with f of x bigger than 0, this point with y, where fy is bigger than 0. Therefore, for this point, all right, over this product space, the product of f of x times f of y has to be bigger than 0. That's what we mean by the product space. All right, to appreciate it, let's look at this example. So here we have the John PDF, John probability function. So I just call it density function, but straight speaking, it's the probability function. So x takes two values only, 2 and 4. Y takes the value 1, 3, and 5. And these are the corresponding probabilities for x equals certain value and y equals certain value. Outside that, it is 0. Make sure that every one represents a probability. In this case, is bigger or equal to 0. And also sum up equal to 1. So sum up equal to 1. All right, so this is the f of x. So f of x, when x equal to 2, is 0.4. When x equal to 4, it is 0.6. And this is f of y. All right, so we can work out from the John distribution, the marginal distribution of x and y respectively. So now, my question is, are x, y are independent? So, what I have to do is to check f of x1, f of x2 times f of y1, whether this is equal to f of xy, 2 and 1, whether this is true. So that means 0.4 times 0.25. The product equal to 0.1. So at least f of x times f of y equal to f of xy, the John probability, for x equal to 2 and for y equal to 1. But that's not good enough. You have to check all the possible xy values. So that means you have to check f of x2, f of y3, whether this is equal to f of xy, 2 and 3, and so on. Altogether, you have to check 6 of them. How about f of x 3 and f of y 2? This is also equal to f of xy at 3, 2. This is also true. Because, what is this? 0. What is this? 0. What is this? 0. So it's also true. That means it's true for all the xy. Usually we just look at the points with non-zero probability. All right. Usually the 0 probability will hold. So in this case, we check. You see, this is what? I check x equal fx2, fy1, and check the others, altogether 6 of them. All this equal to this, and this equal to this. So all these are equal. Therefore, I can conclude that xy are independent. All right, so that's from the definition. But if you look at the joint distribution, right? I look at it, when x equal to 2, basically the probability, all right, is the conditional distribution of x given, of y given x. All right, y given x equal to 2 is equal to, so y equal to 135, then this is equal to 0.1 divided by 0.4. So it's 1/4, 2/4, and 1/4. All right, this is for y. This is the f of y given x. So how about when y equal 135, and then f of y given x when x equal to 4. All right, then it will be 0.15 divided by 0.6. So it is equal to 1/4. 0.3 divided by 0.6, 2/4, 1/4. So you can see that the conditional distribution of y given x, whether x equal to 2 or x equal to 4, it doesn't matter. They are the same. So that's what we mean by independence. So in other words, it doesn't matter what the x value is, your conditional probability is the same. No matter x equal to whatever values. In this case, it's 2 or 4. It will give you the same conditional probability. So that is how we interpret the independence of 2 random variables. All right. That means the information about the other random variable, whether it's equal to 2 or 4 in this case, it doesn't matter. You still have, the y still behaves the same thing. All right. In fact, if you check, f of y is also 1/4, 2/4, and 1/4. All right. All these are the same. All right. It doesn't matter what x is. All right. So this is how we interpret it. All right. Okay. I think yeah. Okay. Maybe I stop here. Example 2 is quite long. All right. So we'll continue on Thursday. So I may have less students in the coming lecture. Right? It's closer to the midterm test.